Find the partial fraction decomposition of x squared over x to the fourth minus 2x squared minus 8. Now, first off, to do this, we have to factor the denominator. Now, there are a couple of ways we can factor. You could try plugging in numbers, see which makes it equal to 0. But the way I chose was I recognize this is in quadratic form, meaning if I square the x squared term, if I square x squared, I'm going to get x to the fourth. So if I say u, a new variable, is equal to x squared, I can rewrite this denominator as u squared minus 2u minus 8. And now I can factor this quadratic in terms of u to u minus 4 times u plus 2, plug back in u equals x squared, and then notice this is a difference of squares, and so this is my final factorization. If you can see that from the original, you don't have to say plug it in for u. You can just go straight to this step, x squared minus 4 times x squared plus 2. But this is our final factorization, so that's what we're going to have. We have two linear factors and a quadratic factor. So we're going to split this up into those three factors. The two linear factors just have a constant in the numerator, and the quadratic factor has a linear expression in the numerator. So we have to solve for a, b, c, and d, and you can see this is a lot of terms because we're going to be multiplying by the entire denominator on the left here. And so for a, the x minus 2 is canceled, but these two fractions are being multiplied. For b, the x plus 2 is canceled, but the x minus 2 and x squared plus 2 are left over. And for the cx plus d, we have the x minus 2 and the x plus 2 that are left over, while the x squared plus 2 is canceled. And so we have a ton of expressions that we have to expand. And so here, first off, I multiplied these two binomials, and this is what I got. I multiplied these two binomials, and this is what I got. And I multiplied these two. These are actually a difference of squares, right? So it becomes x squared minus 4. Next, I distributed the a to all four of these terms, just like that. I distributed the b to all four of these terms, and I multiplied these two binomials, and that is what I got. So this is where we are right now. Now I have to collect all the like terms and factor out the variables so I can equate my coefficients. So in this case, we have ax cubed, we have bx cubed, and we also have cx cubed. So a plus b plus c, factor out the x cubed, that's what we have. For the x squared, we have 2ax squared minus 2bx squared and plus 2d, or not 2d, just dx squared. So that's what we're going to have as the coefficient of our x squared term. For our linear term, we have 2ax, we have 2bx, and minus 4cx. There we go. So that's our coefficient of the x term. And for our constants, we have 4a minus 4b minus 4d. And so that's what we have. And so what we're going to do is we're going to equate coefficients. So in order for the right side to be equal to the left side, this coefficient of x cubed must be equal to 0 because there is no x cubed term on the left. So we want this to cancel out. And so a plus b plus c equals 0. Here, the x squared coefficient has to be equal to the x squared coefficient here, which is 1. And so this expression has to be equal to 1. Again, there's no x term on the left side of this equation. And so the coefficient on this x has to be equal to 0. And finally, there's no constants on the left side of the equation. And so the sum of our constants here have to be equal to 0. And so these are our four equations which we have to solve a system to get all four of the variables. And so we have a system of equations with three variables. There are multiple ways to solve this. You can use elimination. It might almost be easier. I'm not sure. But what I did is I solved for b and c in terms of a with equation 1 and 3. So you can see b is negative a from the first equation, and c is equal to a from the second equation. And now I can sub that in into equation 2. So b is negative a, so I plug that in, and c is a. So now I have an equation all in terms of a. And so I have a plus a plus a, 3a equals 2, and so a is equal to 2/3. And again, we can plug that into our original, or our two equations here. So b must be negative 2/3, and c is also equal to a, so it's 2/3 as well. And so we can plug that into our original expression. We have a, which is 2/3, so we have 2/3 over x minus 1, bx plus c, b is negative 2/3, c is 2/3, so we have negative 2/3 x plus 2/3. And we can actually simplify, first off, this first fraction by moving the 3 into the denominator. That just kind of looks cleaner. So we have 2 over 3 times x minus 1. Here what we could do is we can actually factor out a negative 2/3 from both terms in the numerator. So we end up with just x minus 1 and then this fraction out front, which in that fraction we can move the 3 into the denominator. So you can see this looks a little cleaner than what we had originally. But all three of these are equivalent, and they're probably all correct. So this will be our final answer.